All right, let's talk about the Himalayas. I mean, they're not just mountains, right? They're this incredible crown sitting on top of India. But this isn't going to be some dry geology lesson. No, this is the epic story of how one massive geological event literally shaped an entire subcontinent. So, yeah, let's get right into it.
So, let's kick things off with a pretty big question. How did one single mountain range come to define an entire subcontinent? I mean, think about it. We see them as these giant, snowy peaks, but there's so much more than that. They're a life force, they control the climate, they're woven into the culture. You could almost say that the story of the Himalayas is the story of India. It's that important. Okay, so to really get how the Himalayas even came to be, we've got to jump in a time machine, and I mean way back. Back to a time when the world map looked nothing like it does today. This whole story starts with a collision of continents.
Just look at this timeline. It's mind-boggling, right? So, around 200 million years ago, this giant supercontinent, Pangaea, starts to crack apart. Fast forward a bit, and the piece that would one day become India breaks off from the southern landmass called Gondwanaland. And then it just starts drifting north for millions and millions of years. Until about 50 million years ago, bam, it collides with the massive Eurasian plate. And we're not talking about a little fender bender here. This was one of the most powerful, dramatic collisions our planet has ever seen. And guess what? It's still happening.
So, what does that actually look like, a collision of continents? The best way to picture it is like a super slow motion car crash. Imagine two cars hitting head on. The hoods don't just stop flat, right? They crumple, they buckle, they shoot upwards. Well, that's pretty much what happened to the Earth's crust. The incredible pressure from the Indian plate smashing into the Eurasian plate literally folded the land, pushing it higher and higher and higher. That's how you get a fold mountain. That raw power is what built the Himalayas. Okay, so now we know how they were born. But what exactly are the Himalayas? Because it's not just one big wall of mountains, you know? It's way more complex. It's actually a massive system, made up of three distinct ranges, all running parallel to each other. And each one has its own vibe, its own personality. So let's take a little tour. This chart breaks it down perfectly. Think of it like three giant steps going from north to south. You start at the top with the Greater Himalayas, or the Himadri. These are the giants, averaging around 6,000 meters, always covered in snow. Then you step down to the Lesser Himalayas, the Himachal. A little lower, super scenic valleys. This is where you find famous spots like Shimla. And then the final step down, you have the Outer Himalayas, the Shivaliks. These are basically the foothills, made up of sediment washed down from the bigger mountains. Yeah, the Greater Himalayas, the Himadri. This is the main event. This is the heart of the whole system. We're talking about a massive, unbroken wall of rock and ice. It's here you'll find the absolute titans of our planet, like Mount Everest and Kanchenjunga. They're so high they're always covered in snow, and all that ice and snow feeds the glaciers that become the source for some of Asia's most important rivers. All right, so tucked in just south of those massive peaks, you get the Lesser Himalayas, also known as Himachal. Now these are a bit lower, not quite as imposing, but what they lack in sheer height, they more than make up for in beauty. This is the postcard version of the Himalayas for many people. Think stunning, green valleys like Kashmir, Kangra, and Kulu. It's no wonder this is where you find all those famous, beautiful hill stations. Okay, let's pause here and zoom in on the map, because I want to clear something up. There's a common mix-up when people talk about India's highest peaks, and once you get it, it's a really cool little piece of geographical trivia.
Right. Here's the key thing you need to know. North of the main Himalayas, there's another separate mountain system. It's called the Trans-Himalayas. Geologically, it's a different beast altogether. And the most famous range within the Trans-Himalayas, that would be the incredible Karakoram Range.
So that distinction brings us to this really specific question. Is K2 India's highest Himalayan peak? See that word? Himalayan? That one word is the key to the whole thing. It all comes down to the difference we just talked about.
And boom, here's the answer. It's actually a two-part thing. K2, that monster of a mountain, the second highest in the world, it is India's highest peak, no question. But it's in the Karakoram Range, which is part of the Trans-Himalayas, not the main Himalayas. So the highest peak that's actually in the Indian section of the Greater Himalayas is Kanchenjunga. It's a subtle point, but a super important distinction. So we've talked about how they formed, what they're made of. But now for the big one, the so what? Why do these mountains matter so much? How can one geographical feature have such a massive, profound impact on the lives of literally hundreds of millions of people? It all comes down to their legacy. I mean, first off, they are literally the water towers of Asia. The glaciers up there are the source for rivers like the Ganga and the Yamuna, the absolute lifeblood for everyone living downstream. Then they're this giant climate regulator. They act like a huge wall, blocking cold winds from the north and, crucially, trapping the monsoon rains that the subcontinent depends on. And beyond all that, they're a natural boundary, a fortress, and are just deeply, deeply woven into the culture and spirituality of India. And here's a wild thought for you. This story is not over, not by a long shot. That collision we talked about, the one that started 50 million years ago, it's still happening, right now, as we speak. The Indian plate is still relentlessly pushing into Asia. And because of that, the Himalayas are still growing. They're getting taller by about 2.5 centimeters, that's roughly an inch, every single year. See, these mountains aren't just some static, ancient feature on a map. They are alive. They're breathing. This incredible geological epic is still being written, in real time, right under our feet. Which leaves you with a pretty mind-bending question, doesn't it? If this is what 50 million years has already built, what kind of story will these mountains tell in another million years?